On September 15, 2017, at 4:55 in the morning California time, while most of the world was still asleep, a room full of NASA engineers sat in absolute silence, staring at a single green spike on a screen. That spike was the radio signal of Cassini, a spacecraft the size of a school bus that had spent 13 years orbiting Saturn, 1.4 billion kilometers from Earth. It had cost almost $4 billion. It had rewritten the textbooks on an entire planetary system, and it was still working. Yet every person in that room knew exactly what was about to happen, because they had planned it themselves, down to the second, years in advance. At that very moment, Cassini was plunging into Saturn's atmosphere at 113,000 kilometers per hour, a speed that would take you from Paris to New York in about 3 minutes. The thickening air was tearing at it, while it fought with everything it had to keep its antenna pointed at one pale dot in the darkness: Earth. Then the green spike collapsed into flat noise. People who had given 20, even 30 years of their lives to this machine stood up, held each other, and cried. And here's the part almost nobody understands. NASA did not lose Cassini. NASA destroyed it deliberately. And the reason is one of the most extraordinary stories in the history of exploration. Because the thing that forced them to kill their greatest spacecraft was that spacecraft's own greatest discovery. This is the story of a machine that found a hidden ocean on the far side of the solar system, raised the biggest question humanity has ever asked, and was sentenced to death for it. To understand why that morning hurt so much, you need to understand what it took to get there. Cassini was born in the 1980s, when everything we knew about Saturn came from the Voyager probes, which raced past the planet in a matter of days and left more questions than answers. What was hiding under the impenetrable orange smog of Titan, Saturn's giant moon? What were the rings actually made of? The only way to find out was to stop and stay. Cassini became the most complex interplanetary spacecraft ever built, almost 7 meters tall, 5,700 kilograms, carrying 12 instruments from 27 nations, with a European lander named Huygens bolted to its side. It was so ambitious and so expensive that it barely survived cancellation in Washington. It carried 33 kilograms of plutonium, the only way to make power where sunlight is 100 times weaker than on Earth. And that alone drew protesters to the launch gates in October 1997. At 4:43 in the morning on October 15th, a Titan IV rocket, the most powerful in the American fleet, tore into the pre-dawn sky over Florida, carrying 2 decades of work in the careers of thousands of people. Here is what most people don't realize. Cassini could not fly straight to Saturn. No rocket on Earth was powerful enough to throw 6 tons that far. So navigators drew a route that looks almost absurd. Inward first, toward Venus, around Venus a second time, back past Earth, and finally out past Jupiter, stealing a little momentum from each planet like a relay runner grabbing a push from a teammate. Almost 7 years, 3.5 billion kilometers, 4 gravity assists, every one of them timed to perfection. Then, on the night of June 30th, 2004, came the moment that decided everything. To enter orbit, Cassini had to thread a gap in Saturn's rings, where a particle the size of a sand grain hits like a rifle bullet, and then burn its main engine for 96 minutes without a single fault. A radio signal from Saturn takes more than an hour to arrive, so nobody on Earth could help. Mission Control could only listen. The signal came. For the first time in history, a machine from Earth was in orbit around Saturn. And almost immediately, it began finding things nobody was prepared for. The first target was Titan. Titan is enormous, larger than the planet Mercury, and it is the only moon in the solar system wrapped in a thick atmosphere, half again as dense as Earth's. For decades, it had been a locked door. An opaque orange haze hid the entire surface. Some scientists expected a global ocean of liquid natural gas, others a frozen desert. There was exactly one way to find out. On Christmas Day 2004, Cassini released the passenger it had carried for 7 years. The Huygens probe, a saucer just 2.7 meters across, drifted silently away and coasted for 20 days toward that orange wall. It had no engines, only batteries, and exactly one attempt. On January 14, 2005, Huygens hit Titan's atmosphere and began the most distant landing ever attempted, roughly 1.2 billion kilometers from home. That record still stands today, 2 decades later. For almost 2.5 hours, the probe descended under parachutes through air at minus 180 degrees Celsius. And when the haze finally thinned, its cameras began sending back something nobody could quite believe. River channels, branching valleys carved into hillsides, shorelines, coastlines, drainage basins. A landscape that looked hauntingly like Earth seen from a small plane. Except nothing here was what it seemed. On Titan, it is so cold that water ice freezes harder than granite, and it plays the role of rock. And the liquid that carved those rivers was not water, it was methane. Natural gas falling from orange clouds as rain. Huygens touched down with a soft squelch, in soil like wet sand under a thin crust. Scientists compared it to creme brulee, surrounded by rounded pebbles of water ice, rounded the way riverbed stones are rounded, by tumbling in a current. The little probe kept talking from the surface for more than an hour, far longer than anyone dared to hope. Over the following years, Cassini's radar peeled away the rest of the mystery. In Titan's north, it found true seas of liquid methane, and they are not puddles. Kraken Mare rivals the Caspian Sea in size and reaches hundreds of meters deep. Titan turned out to be the only world we know of, other than Earth, with rain, rivers, lakes, and seas on its surface. A complete, twisted mirror of our own water cycle, running at minus 180 degrees. A discovery like that should have been the crown jewel of the entire mission. And this is where the story takes its turn. Because Titan wasn't the biggest discovery. The biggest one was hiding on a moon so small and so boring looking that it was barely on the priority list. Enceladus is tiny, barely 500 kilometers across, about the width of Arizona. Before Cassini, it was a footnote, a blinding white dot, the most reflective object in the solar system, which everyone assumed was dead. Moons that small are supposed to have frozen solid billions of years ago. The first warning came from an instrument that doesn't take pictures at all. In early 2005, as Cassini flew past, its magnetometer noticed that Saturn's magnetic field was bending around Enceladus, the way river water bends around a stone. That only happens when something is in the way. The tiny moon seemed to have an atmosphere. But a body that small has nowhere near the gravity to hold one, which could only mean one thing. Something on Enceladus was actively pumping gas into space, right now. The team rewrote the flight plan and went in closer, and every expectation broke at once. The South Pole, which should have been the coldest place on the moon, was warm, with 4 giant fractures slashed across it, quickly nicknamed the Tiger Stripes. And then Cassini looked back at Enceladus with the sun behind it and captured the image that changed the mission forever. Geysers. More than 100 jets of water vapor and ice crystals, erupting from those fractures and towering hundreds of kilometers into space. A moon was firing its own insides into the void, continuously, like a snow globe with a crack in it. Some of that ice escapes and spreads along the moon's orbit, And in one stroke, this solved another old mystery. Saturn's faint E-ring is not debris. It is Enceladus's snowfall. And then NASA made one of the boldest calls in the history of robotic spaceflight. If a moon is spraying its own interior into space, you don't need to drill through kilometers of ice to sample its ocean. You can simply fly through the spray. So Cassini did, again and again, lower each time, until October 2015, when it skimmed just 49 kilometers above the surface, straight through the heart of the plume at 30,000 kilometers per hour, tasting an alien ocean with instruments never built for it. The results came in like footsteps on a staircase, each one heavier than the last. The ice grains were salty, meaning the water had touched rock. The moon's subtle wobble proved the ice shell floats completely free of the core, meaning the ocean isn't a pocket, it is global. Microscopic grains of silica in the spray could only have formed in hot water, above 90 degrees Celsius, meaning the seafloor has hydrothermal vents. And in April 2017 came the discovery that made headlines around the world. The plume was laced with molecular hydrogen. On the floor of Earth's oceans, entire ecosystems thrive in total darkness around hydrothermal vents, feeding on exactly this chemistry, no sunlight required. Cassini had found liquid water, chemical energy, and organic molecules, every fundamental ingredient for life as we know it, inside a tiny frozen moon. And the data kept giving even after the spacecraft was gone. Years later, scientists digging through Cassini's old measurements found complex organics, and in 2023, phosphorus, the last missing item on the list. A forgotten ball of ice had just become arguably the most promising place to search for alien life in the entire solar system. And that discovery is precisely what killed Cassini. By 2017, after 20 years in space, Cassini was running out of the propellant it used to steer. Once that was gone, it would become a derelict. Almost 6 tons of dead metal tumbling around Saturn on an orbit no one could predict or control, for decades, maybe centuries. And Cassini was not sterile. It left Earth before anyone knew what was waiting at Saturn, and some Earth microbes are terrifyingly hard to kill. They can shut down and survive years of vacuum, radiation, and deep cold. Waiting. Now play that forward. Sooner or later, an uncontrolled Cassini could slam into Enceladus and crack open near those fractures, near the ocean. If even a handful of Earth bacteria survived the trip and reached that water, we would face a nightmare scenario. One day we finally discover life on Enceladus, and we can never be certain whether we found aliens or simply met our own contamination. The most profound question our species can ask, are we alone, would be poisoned forever. So the rules of planetary protection left exactly one option. While engineers still had control, they would spend Cassini's last drops of fuel to aim it at the one place where nothing survives: Saturn itself. Sit with the irony of that for a second. If Enceladus had turned out to be a dead rock, Cassini could have been parked in a distant graveyard orbit and left to drift forever. Instead, its reward for finding a world worth protecting was a death sentence. But NASA engineers do not waste a death. If the spacecraft had to fall into Saturn anyway, then on the way down, it could go where no mission would ever be allowed to go while trying to survive. In April 2017, Cassini flew past Titan one last time, and navigators used the moon's gravity to hurl the spacecraft somewhere unthinkable, into the gap between Saturn and its rings. That gap is only about 2,000 kilometers wide, a keyhole by cosmic standards, with the planet's cloud tops on one side and a wall of orbiting ice on the other. And Cassini would be threading it at 124,000 kilometers per hour, fast enough that a single pebble could end everything. No machine had ever flown there. The models said it was probably survivable. Probably. On the first pass, the team turned the spacecraft's 4-meter radio dish forward, like a shield, pointed into the unknown. For 20 agonizing hours, Cassini was silent. Then the signal returned. Cassini threaded that keyhole 22 times, and what it found in those final orbits rewrote Saturn one last time. The gap turned out to be almost perfectly, eerily empty. Engineers had braced for a sandblasting. Instead, the dust detector heard nearly nothing. They called it the Big Empty, and to this day, nobody fully knows why it is so clean. The rings, meanwhile, turned out to be raining. Every half hour, enough ring material pours down into Saturn's atmosphere to fill an Olympic swimming pool. Saturn's rings are not permanent. They are dissolving in front of our eyes. And by feeling the rings' gravity from the inside, Cassini finally weighed them, and the answer stunned everyone. The rings are light, which means they are young, perhaps only tens of millions of years old. When the first dinosaurs walked the Earth, Saturn may have had no rings at all, and in another 100 million years, they may be gone again. We are not looking at an eternal monument. We caught Saturn by pure luck in its brief, spectacular moment. And Saturn's magnetic field turned out to be perfectly aligned with its spin axis, something every theory says is impossible. That secret, it kept to the very end. Then, on September 11th, 2017, Titan reached out one final time. A distant pass, a gentle gravitational tug that engineers called the goodbye kiss, bent Cassini's path just enough that its next approach would not skim over Saturn's atmosphere, but into it. From that instant, nothing in the universe could call the spacecraft back. NASA was no longer flying Cassini. Physics was. On September 14th, Cassini took its final photographs. Titan on the horizon, Enceladus slowly setting behind Saturn's limb, and last of all, a dark patch of clouds on Saturn's night side, faintly glowing in light reflected off the rings, the exact spot where, hours later, it was going to die. Then it turned its antenna toward Earth for the last time and never looked away again. And now comes the detail that makes this story almost unbearable. Saturn was 1.4 billion kilometers away, so far that radio waves need 83 minutes to cross the Gulf. So on that final morning, as more than 1,500 engineers, scientists, and their families gathered at Mission Control and watched Cassini's signal live on the screens, the spacecraft they were watching no longer existed. It had already been gone for 83 minutes. What they were watching was a farewell message from a machine that was already dead, still racing toward them at the speed of light. In its true final minutes, Cassini hit the atmosphere and did something no spacecraft had ever done. It sampled Saturn's air directly and streamed the data home in real time. Its tiny thrusters, each pushing with roughly the force of a tennis ball resting in your palm, fought the atmosphere of the second largest planet in the solar system. 10% power, 50, 100. For 91 seconds, Cassini held its antenna locked on Earth, longer than the models predicted. Of course it did. Then the line went flat, and for one heart-stopping moment, a tall green spike flickered back onto the screens, as if Cassini was fighting its way back to us. It was only an echo, a stray lobe of the dying radio beam. But for a second, an entire room stopped breathing. The project manager keyed his microphone and quietly called the end of mission. The room rose into applause and tears. And somewhere in Saturn's sky, the spacecraft broke apart, flared like a meteor, and vaporized, its atoms scattering into the clouds. Cassini did not crash into Saturn. Cassini became part of Saturn. Any future probe that ever samples that golden sky will breathe in a few atoms of a machine from Earth. The final numbers still sound like fiction. 20 years in space, 7.9 billion kilometers traveled, nearly 300 orbits of Saturn, more than 450,000 photographs, 6 new moons discovered, and thousands of scientific papers, with new ones still being written today. But the real legacy is what comes next. Because of what Cassini found, NASA is building Dragonfly, a nuclear-powered drone that will fly over the dunes of Titan. Europa Clipper is racing toward another hidden ocean at Jupiter right now, and engineers are sketching missions that would return to Enceladus and land beside the geysers. If one of them ever finds life, the trail of that discovery will lead straight back to a machine that was destroyed to keep that life safe. We didn't kill Cassini because we stopped believing in it. We killed it because it made us believe that somewhere out there, in a dark ocean under the ice, there might be someone worth protecting. If this story gave you chills, hitting the like button genuinely helps YouTube show it to more people who would appreciate it. And subscribe, because the next chapter is unfolding right now. Europa Clipper, the largest interplanetary spacecraft NASA has ever built, is on its way to an ocean moon hiding twice as much water as all the seas of Earth combined. And it is flying straight into a radiation field strong enough to kill its electronics in a matter of days.